angle theta in standard position has its terminal arm passing through the point 3, -5. Find the values of the three primary trigonometric ratios for angle theta. Leave your answers as exact values in simplified form. Also, find the value of theta, rounded off to the nearest tenth of a degree. To determine the three primary trigonometric ratios, use the definitions of sine, cosine, tangent, as well as Pythagorean theorem. Sine theta equals the y value divided by r, the radius. Cosine theta equals x over r. Tangent theta equals y over x. And Pythagorean theorem, x squared plus y squared equals r squared. Looking at a coordinate grid, drawing our angle theta in standard position with point x, y on the terminal arm, we can see that x corresponds to the adjacent side relative to angle theta, y corresponds to the opposite side, and r corresponds to the hypotenuse. Here, x and y are given as a point through which the terminal arm passes. R can be calculated using x and y from Pythagorean theorem. To determine the angle theta, use inverse, sine, cosine, or tangent of the corresponding ratio. Ignore the sign of the trig ratio, though, as it only represents which quadrants the terminal arm could be in. This will then give the reference angle. Once we have the reference angle and the quadrant containing the terminal arm, the angle in standard position can then be calculated. For an angle in quadrant 1, the angle is equal to the reference angle. In quadrant 2, 180 degrees minus the reference angle. In quadrant 3, 180 degrees plus the reference angle. And in quadrant 4, 360 degrees minus the reference angle. For this question, our point is 3, -5. This means that x equals 3 and y equals -5. From Pythagorean theorem, we can calculate r as the square root of 3 squared plus -5 squared, or the square root of 34. First of all then, for sine equals y over r, plugging in y equals -5 and r equals the square root of 34. We then simplify this by rationalizing the denominator. This gives a result of -5 root 34 over 34. For cosine theta equals x over r, again we plug in x and r. Here we have 3 over root 34, and again rationalizing the denominator, we get cosine theta equals 3 root 34 over 34. For tangent theta, we have y over x. Here we substitute -5 for y and 3 for x, giving us tan theta equals -5 over 3. To figure out the angle, we will first figure out the reference angle. In this case, I'm going to use tangent and take the inverse tangent of 5 over 3. Note again that I'm ignoring the negative sign from the value of tangent theta. This gives a reference angle then of 59.0 degrees. We know that the point 3, -5 is in quadrant 4. The value then for theta is 360 degrees minus the reference angle of 59.0 degrees. giving theta equals 301.0 degrees.